All right, let's talk about one of the most powerful ideas in all of math, the derivative. Now, I know it might sound a little intimidating, right? But stick with me, because it's really all about understanding the world in a single fleeting moment. So let's just dive right in.
I want you to really think about this for a second. Let's say you're driving. Figuring out your average speed over an hour, that's easy. But what about your speed right now, at the exact instant you look down at your speedometer? How does your car even know that? Well, that very question is exactly why derivatives were invented.
And this gets us to what I like to call the right now problem. It's the challenge of making that jump from understanding change over a big chunk of time to understanding it as it's happening in a single tiny instant. Like we said, calculating your speed over 60 miles is simple, distance divided by time. But at a single point in time, well, how much distance have you traveled? 0. And how much time has passed? 0. And you just can't divide 0 by 0. It doesn't work. So how do we solve this puzzle?
We solve it with a truly brilliant mathematical tool. We're going to put a name to the solution of our right now problem, and that name is the derivative.
So, what is this thing really? A derivative, and you'll often see it written as dy over dx, is just a tool for measuring the rate of change at any given instant. It's the math that lets us find the speed right now, or the growth of a company right now, any change happening at one specific moment.
Okay, so we know what it is, but how does it actually work? Let's break down the step-by-step mechanism behind this whole idea.
It's a really beautiful and logical four-step process. First, you start with a function, which is just a rule that connects two things, like distance and time. Second, you find the average change over a decent-sized chunk of time. Third, and this is the genius part, you make that chunk of time smaller and smaller and smaller until it's almost 0. And fourth, what you're left with is the exact instantaneous rate of change at that single point. And boom, that's the derivative.
We can boil that whole thing down to its essence. You start with a function, you measure the change, you push that change to its limit as things get smaller, and what you get is the derivative. It's this elegant flow from a general idea to a super precise fact. And amazingly, we can actually visualize this whole thing.
Now check this out. Imagine a curve on a graph that shows your journey. A secant line connects 2 points on that curve. Its slope is your average speed over that time. But as you bring those 2 points closer and closer together, that line starts to pivot until it just kisses the curve at one single point. That new line is called the tangent line, and it represents the change at that exact instant.
And this is the key takeaway right here. The slope, the steepness of that tangent line is the derivative. That single number tells you exactly how fast things are changing at that precise moment. We essentially turned a geometry problem into a speed problem. How cool is that?
And this isn't just some abstract math concept, not at all. It's built into the world all around us. In fact, you're seeing derivatives in action every single day. You probably just don't realize it.
Let's circle all the way back to our first question. Your car's speedometer? It's basically a real-life derivative calculator. It's constantly measuring the instantaneous rate of change of your distance with respect to time. And that's what gives you your speed, right now.
Or think about finance. Analysts use derivatives all the time to figure out how quickly stock prices are changing. A steep positive slope means a stock is growing fast. A flat slope means it's stalled. It's all about that instantaneous rate of change.
Ever been on a roller coaster? Well, engineers are using derivatives to calculate the exact slope of the track at every single point. That's how they make sure all those twists, turns, and drops are not just thrilling, but also perfectly safe. And what about that phone in your pocket? The motion sensors that let you play games or track your steps. They're constantly calculating derivatives to understand how your position is changing from 1 millisecond to the very next.
So, after all of these examples, what's the one big idea you should walk away with? It all boils down to a really powerful concept: measuring change.
The derivative is the instantaneous rate of change. It's the language of math we use to describe the exact rate something is happening, not over a year or an hour, but at a specific single moment in time.
And this really sums it all up perfectly. As the quote says, derivatives may sound complex, but at their core, they simply measure change, something that's happening all around us. Behind the fancy name and the symbols, that's all it is. It's a tool for measuring a fundamental process that governs everything from our motion to our economy.
So the next time you see something in motion or a graph that's trending up or down, just remember the hidden math that's at play. Now that you know what they are, what other instantaneous change is happening all around you do you think derivatives could help you see?